Hello friends, I Deepak Prajapati welcome you on my channel Engineering Mathematics djganit. Today we are going to discuss about mean and variance of a binomial distribution. We have already discussed the definitions of mean and variance for discrete as well as continuous random variable. But for this special discrete probability distributions, we have ready-made formulas for mean and variance. So we will first see what are the mean and variance of a binomial distribution, and then we will do some problems based on those two formulas. So suppose x is a binomial random variable with parameters n and p. N means number of trials, P means probability of success. Then the mean mu of this binomial random variable x is given by mu equal to, this is another notation, expected value of x equal to n into P, that is number of trials into probability of success. So if our random variable is binomial random variable, we can directly find out its mean or expected value using this formula, number of trials into probability of success. We are not going into the details of the proof of this formula. We will just remember that if we want to find out mean of binomial distribution, then it is given by number of trials into probability of success, and the variance sigma square of this random variable is sigma square equal to n into p into q, where q is nothing but 1 minus probability of success, that is probability of failure. So sigma square, that is variance of binomial distribution, is number of trials into probability of success into probability of failure. So we will remember these two formulas. And the standard deviation is nothing but square root of variance. So variance is npq, therefore standard deviation is square root of np into q. So now we consider some examples based on these two formulas. So example number 1, a particular telephone number is used to receive both voice calls and fax messages. Suppose that 25% of the incoming calls involve fax messages, and consider a sample of 25 incoming calls. And the question is, what is the expected number of calls among the 25 that involve a fax message? And second question is, what is the standard deviation of the number among the 25 calls that involve a fax message? So first we have to check whether this problem is of binomial distribution or not. So here we are given some particular telephone number, and that telephone number is used to receive voice calls and fax messages, and it is given that 25% of the incoming calls involve fax messages. That means if we consider the event that a telephone call involves fax messages, then probability of a telephone call involving fax messages, it is 25%, that is given, that is 0.25, and we have a sample of 25 incoming calls. So for each incoming calls we can check whether that call involves voice call or fax messages. So for each incoming call there are two possibilities, either it is a voice call or it is a fax message. we are asked to find out expected number of calls among the 25 that involve a fax message. So here from this we have the idea that which random variable we have to consider. So we are asked to find out the expected number of calls that involve a fax message. Similarly, we are asked to find out the standard deviation of the number among the 25 calls that involve a fax message. So from this we may have the idea that which random variable we have to consider. So here we will consider the random variable capital X equal to the number of telephone calls that involve a fax message. So capital X equal to the number of incoming calls that involve a fax message among n equal to 25 incoming calls. So number of trials is n equal to 25 because we have a sample of 25 incoming calls. So for each incoming call there are only two possibilities, either it is a voice call or it involves a fax message, and we define capital X equal to number of calls that involve a fax message. So from this we can consider success as the event that incoming call involves a fax message. So the event that incoming call involves a fax message is assigned as success, and it is given that 25% of the incoming calls involve fax messages. So probability of success is P equal to 0.25. So this is the example of binomial probability distribution. Because number of trials are finite, there are only two possible outcomes for each trial. Either incoming call involves voice call or fax messages, and if we consider success to be incoming call involving a fax message, then probability of success remains constant 0.25 for each trial, and all the incoming calls are independent. So this is the example of binomial probability distribution. So we can say that capital X is a random variable which is binomial random variable with n equal to 25, and probability of success is 0.25, and therefore the expected number of calls that involve a fax message, that is nothing but expected value of this random variable X. And because X is a binomial random variable, we write down the formula for expected value of binomial random variable, that is n into p. So number of trials is 25 and probability of success is 0.25. So we obtain 6.25. So the expected number of calls that involve a fax message is close to 6.25. So even if X is assuming integer values, expected value of X need not be an integer value, but we have the idea that expected number of calls is close to 6.25. that this is the mean of this random variable X. Similarly, we have the formula for variance of X. So variance of X is n into p into q. N is 25, p is 0.25, and q is nothing but 1 minus p, that is 1 minus 0.25, which is 0.75. So variance of X is 4.6875. But we are asked to find out standard deviation. So standard deviation is nothing but square root of variance, and if we take square root of this 4.6875, we are having 2.1651. So this is the standard deviation of the number of calls that involve a fax message. Okay, so in this way we can easily find out this expected number of calls, that is mean of random variable X and standard deviation of random variable X if random variable X is a binomial random variable. So all you have to do is you have to check whether the random variable under consideration is a binomial random variable or not. If it is binomial random variable, you can apply the formulas. Mean is n into p and variance is n into p into q. We consider one more example. The mean and variance of binomial distribution are given 4 and 4 by 3 respectively. So using this information you have to find out the probability of the event capital X is greater than or equal to 1. So it is given that capital X is a binomial random variable, but we are not given parameters n and p. But what is given? We are given the mean, that is mu is 4 and variance, that is sigma square, is given to be 4 by 3. So using this information we have to find out probability of this event. But for probability of this event we require these values of these two parameters n and p. So first we find out values of parameters using this mean and variance. So given that mean is 4 and variance is 4 by 3, that is mu equal to 4 and sigma square is 4 by 3. But we know that if distribution is binomial, mean is nothing but n into p. So we replace mu by n into p and we are having n into p equal to 4. Similarly, sigma square of a binomial distribution is npq. So we put sigma square equal to npq and we obtain 4 by 3. So from these two equations we have to decide small n and small p. So you can see we have n into p in both the equations. So we can divide this equation by this equation. So if we divide these two equations, so division of left hand side, that is npq divided by np equal to division of right hand sides, that is 4 by 3 divided by 4. So 4 will cancel out and we are left with 1 by 3. And here n into p will cancel out and we are left with small q. So small q is 1 by 3. Q is nothing but probability of failure. And we know that q equal to 1 minus p. So 1 minus p is 1 by 3. Therefore p equal to 1 minus 1 by 3, that is 2 by 3. So we obtain probability of success as 2 by 3. Now how to obtain value of n? So we can use this equation. We have n into p equal to 4 and p is 2 by 3. Okay, so using this we obtain number of trials. N equal to 4 by p. P is 2 by 3, so 1 by 3 is 3 by 2. And this 2 will cancel out and we obtain number of trials equal to 6. So now we have the parameters n equal to 6, p equal to 2 by 3. So using parameters we can write down the formula for probability mass function of a binomial random variable. So it is given by probability that x equal to small x equal to ncx p raised to x q raised to n minus x. And then we put n equal to 6 and p equal to 2 by 3. So 6cx, p is 2 by 3 and q is 1 by 3. And here also we put n equal to 6. And the possible values of random variable are x from 0 to 6 because n is 6. Now we are asked to find out this probability that capital X greater than or equal to 1. So this we can write as 1 minus probability that capital X is less than 1. Okay, because we know that x less than 1 and capital X greater than or equal to 1 are which type of events? complementary events. So sum of their probabilities must be equal to 1. So these two events are complementary events, therefore we can write probability that x greater than or equal to 1 equal to 1 minus probability that x is less than 1. So the value of x which is strictly less than 1 is 0 only. So we obtain this is equal to 1 minus probability that x equal to 0, and then we put x equal to 0 in this formula. So if I put x equal to 0, I will obtain 6 is 0, 2 by 3 raised to 0, 1 by 3 raised to 6 minus 0, that is 6. And this is going to be 1, 6 is 0 is 1, this is also 1, and we have 1 by 3 raised to x, that is 728 divided by 729, and after simplification we obtain this probability that x is greater than or equal to 1 is 0.9986. Next example. If on an average 8 ships out of 10, if on an average 8 ships out of 10 arrive safely at a port, find the mean and standard deviation of the number of ships out of a total of 1600 ships. So how we are asked to find out mean and standard deviation of the number of ships out of a total of 600 ships. So first we have to define random variable, so that you can have the idea from this. Find the mean and standard deviation of the number of ships out of a total of 600 ships. So this you can consider as your random variable, but we have to add this arrive safely. So the random variable under consideration is the number of ships that arrive safely out of a total of 1600 ships, that is total number of trials is n equal to 1600. So we define capital X equal to the number of ships that arrive safely among n equal to 1600 ships. Now for each ship there are only two possibilities, either it arrives safely or it does not arrive safely. But here random variable is number of ships that arrive safely. So we consider success as the event that ship arrives safely. Now it is given that on an average 8 ships out of 10 arrive safely at a port. So the probability of success is 8 divided by 10, that is 0.8. So P is 0.8. And number of trials is n equal to 1600. So once we have n and p, we can easily find out mean and variance of x. And it is clear that x is a binomial random variable with n equal to 1600 and p equal to 0.8. So mean of x is mean mu equal to n into p, that is 1600, that is value of n into 0.8, that is p. So 1280. And standard deviation of x is square root of variance of x. So square root of np into 1 minus p. So n is 1600, p is 0.8 and 1 minus p is 0.2. Okay, so after simplification the standard deviation is 16. Hence the mean and standard deviation of the number of ships that arrive safely is 1280 and 16 respectively. Okay, so in this way you can do the problems related to binomial distribution, and you have to remember these formulas. Mean of a binomial distribution is n into p, and the variance sigma square of a binomial distribution is np into q, where n is number of trials, p is probability of success, and q is probability of failure. So we stop here. This is all about today's session. I hope you like this lecture. If you are watching this channel first time, please subscribe this channel for upcoming lectures as well as upcoming courses. I am going to upload lectures of each mathematics subject of engineering on my channel. So please subscribe my channel for upcoming lectures. Thank you very much.